We're going to look at some different graphs today, graphs that have holes in them, gaps in them, and some that have more than one vertical asymptote. And sometimes we get this curving shape in the middle, and we'll reference that middle point as a vertex. We'll try to identify what that point is. So holes are going to appear in problems 2 and 3. Problem 1 is already reduced. You're not going to have a hole. Problem 4, already reduced. You won't have a hole. But if you're given something that's not reduced and you find something that can cancel, you will have a different equation to work with, but a hole at the x value that came out of that canceled term. So if you cancel x minus 2, it will be at 2. If you have an x minus 5, it will be at positive 5, and you plug it back into the reduced equation. So let's identify what we know about number 1. I know that there are two bad guys on the bottom, so x can neither be negative 4 nor positive 2. That's going to give us two vertical asymptotes. I also know it's Bobo, bigger on bottom, so y equals 0 is the horizontal asymptote. If I were to plug in something like 3 and negative 5, I can identify these shapes. And I also know if I plug in 0 for x, I'm going to get 0, negative 1. So I know my shape down here. What I don't know, however, is this highest point in the middle. So this I'm going to have to come back and find. But this graph had no holes because it was already reduced. Number 2 was not already reduced, so it is going to have a hole. And because x minus 2 is what came out, the hole would be at positive 2. And then whatever you get, if you plug it back in here, I'm going to end up with a negative 1/4. So 2, negative 1/4 is going to be where a hole is, and I'm going to have kind of an exaggerated open circle there. Doing the rest of the shape, I know it's bigger on bottom, so y equals 0 is the horizontal asymptote. I'm looking here. The bad x here would be 6, so over here at 6 I'll have a vertical asymptote. I cannot make this fraction equal to 0, so there's no x-intercept. And 0, negative 1/6, what I get when I plug in 0 for x, is a point. So when I go to graph it, I'm going to go through the hole. The hole becomes part of your puzzle that you have to draw through. If I try to value like 7 and 8, I would identify that I'm up here. On number 3, look what happens when you cancel here. Everything like goes away and you end up with just, well, a normal line like y equals mx plus b. However, because x minus 5 canceled, you have a hole. And the hole is going to be at 5 plus 5, or 10. So think about what we know. If it's a regular diagonal line, there's no asymptotes. I know my line can be graphed by starting at the y-intercept of 5. I'll have a slope of 1. I'll talk about how to do the hole on these in a minute. The x-intercept would be at negative 5, and I would be able to identify my hole this way. The hole is at 5, 10, and so I usually go back with my eraser, and then I exaggerate the hole with a wide open circle so that I know that's where I'm trying to show the hole. The last one, number 4, is also one that's going to have two vertical asymptotes, and this one, unfortunately, is going to have a lot of fractions that come along with it. So I'll start off by looking at my factored form. I know that I'll have two vertical asymptotes, one at 1, the other at negative 3/2, so a little bit further to the left. That's negative 1.5. I know that it's bigger on bottom, so the horizontal asymptote is at 0. If I plug in this y-intercept, so making x equal to 0, I get 0, negative 2/3. So I have an idea in the middle of what's happening. It has to go through this. If I tried values like, since this is 1, if I tried 2 and 3, you're going to find yourself positive. This is negative 1.5, so if you tried negative 2, negative 3, negative 4, testing values, you'll find that curve up here. And then something funny's happening in the bottom. So I have to look at these number 1 and number 4 and do something about vertices. Number 1, the numbers are a little bit cleaner, so let's start with this. So again, two vertical asymptotes. I want to look for a vertex. And I ask myself, what is in the middle of negative 4 and 2? Well, it's negative 1. So if I plug negative 1 back into the original equation, I'm going to get, well, it's a fraction, it's not bad, but negative 2/3 for this, well, I'm calling it a vertex, this highest point right here. So remember that. We're going to need to know that that's a negative 2/3 up there. On number 4, unfortunately, you don't have quite as clean a middle. What's in the middle of 1 and negative 1.5 is going to be negative 1/4. Now here's some math for you. Because I have two vertical asymptotes, I'm looking for this thing called a vertex, and I know that in the middle of those two asymptotes is negative 1/4. Oh goodness, if I have to plug that in, I'm going to use the factored form. 2 times negative 1/4 plus 3, that's 2x plus 3. And then x, so negative 1/4 minus 1. I'm plugging it into this factored version. You're going to end up getting negative 16 out of 25 over 25. So not the prettiest number. I'll help with arithmetic there. And that's telling me that negative 16/25 is that highest y value. So that's all the parts, and then we'll pause and do domain and range.